Right, dear students, today we are going to continue the problems of addition of vectors. Right, the points O, capital A, capital B, capital X and capital Y are such that OA bar is equal to A bar, OA bar is equal to A bar, OA bar is equal to A bar, OB bar is equal to B bar, and OX bar is equal to 3A bar, OX bar is collinear with OA bar, and OY bar is equal to OY bar is equal to 3 times B bar. OY bar is also collinear with B bar. Right? This is given data. OA bar is equal to A bar. OB bar is equal to B bar. OX bar is equal to 3A bar. OY bar is equal to 3B bar. Find Bx bar. Find Bx bar. Write Bx bar, that can be written as Ox bar minus Ob bar. Ox bar minus Ob bar. Ox bar, that is equal to 3A bar minus Ob bar, that is equal to B bar. Now Ay bar that is equal to Ay bar, that is equal to Oy bar minus Oa bar, that is equal to Oy bar. Oy bar is equal to 3B bar minus Oa bar, that is A bar. Right? Bx bar, Ay bar, Bx bar, Ay bar in terms of A bar and B bar. Now, if the point P divides Ay bar in the ratio 1:3, then express BP bar in terms of A bar and B bar. Right? Now, our aim is to find the position vector of P. To find the position vector of P. Right? See, P divides AY. Suppose this is a point P divides AY in the ratio that is 1:3. 1:3. The position vector of A is A bar. The position vector of Y is 3 times B bar. 3 times B bar. Right? Now the position vector of P is, by using section formula, OP bar, that is equal to 1 into OY bar, 1 into OY bar, 3 into OA bar divided by 1 plus 3. That is equal to 1 into OY bar, that is equal to 3 times B bar plus 3 times A bar, 3 times A bar divided by 1 plus 3, that is equal to 4. That is OP bar. Now, BP bar in terms of A bar and B bar. BP bar, that is equal to BP bar, that is equal to OP bar minus OB bar. OP bar minus OB bar. What is OP bar? That is equal to 3B bar plus 3A bar divided by 4 minus OB bar. OB bar is simply B bar. Now take LCM, that is equal to 3 times B bar plus 3 times A bar minus 4 times B bar divided by 4, that is equal to 3A bar minus B bar, 3A bar minus B bar divided by 4, that is BP bar. Right? Once again, I will explain briefly. Given OA bar is equal to A bar, OB bar is equal to B bar, also given OX bar and OY bar. Right. Now first find Bx bar and Ay bar. By using the definition of a position vector, we found Bx bar and Ay bar. Right. Now OP bar. P divides Ay in the ratio 1:3. By using section formula, we found OP bar, that is equal to this. Now finally BP bar. BP bar is equal to OP bar minus OB bar. Simply by taking LCM, we get 3A bar minus B bar by 4. Right. Let us see next problem. In triangle OAB, E is the midpoint of AB, F is a point on OA such that OF is equal to 2 times FA. If C is the point of intersection of OE and BF, then find the ratios OC is to CE and BC is to CF. Right. In triangle OAB, in triangle OAB, this is a triangle OAB, this is O, this is A, and this is B. This is a triangle OAB. Right. Capital E is the midpoint of AB. E is the midpoint of AB. Right. E is the midpoint of AB. And F is a point on OA. F is a point on OA such that OF is equal to 2 times FA. OF is equal to 2 times FA. Right. If C is the point of intersection of OE and BF. Okay, this is OE, this is OE, and this is BF, this is BF. C is the point of intersection of OE and BF. Then find the ratios OC is to CE and BC is to CF. Right. This is a triangle OAB. Assume that let OA bar is equal to A bar. Let OA bar is equal to A bar. OB bar is equal to B bar. OB bar is equal to B bar. Since E is the midpoint of AB, E is the midpoint of AB, the position vector of E, that is equal to OA bar plus OB bar divided by 2, that is equal to A bar plus B bar, A bar plus B bar divided by 2, that is position vector of E. And F is a point on OA such that OF is equal to 2 times FA. OF is equal to 2 times FA. Okay, this is OA. Suppose this is OA and F is a point on OA. OF is equal to 2 times FA. 2 times FA is to FA, that is equal to 2:1. F divides OA in the ratio 2:1. Right. Now OF bar is equal to OF bar. The position vector of O is 0 bar and the position vector of capital A is A bar. Now OF bar is equal to 2 times A bar, 2 times A bar, 1 times 0 bar divided by 3, that is equal to 2 by 3 times A bar, that is OF bar. Right, OE bar is equal to A bar plus B bar by 2. OF bar is equal to 2 by 3rd A bar. Now our aim is to find the ratios OC is to CE and BC is to CF. Right, C is the point of intersection of OE and BF. Right, let OE take OE. Now C is on OE. C is on OE. This is OE. C on OE. This is O bar. This is O bar. This is the position vector of E, that is A bar plus B bar by 2. Suppose C divides OE in the ratio lambda is to 1. That implies OC bar is equal to position vector of C is equal to lambda times OE bar, lambda times A bar plus B bar divided by 2 plus 1 into O bar divided by lambda plus 1, that is equal to lambda by 2 times lambda plus 1, lambda by 2 times lambda plus 1 into A bar plus B bar, that is OC bar. C also lies on BF. C also lies on BF. The position vector of B is B bar. The position vector of F is 2 by 3rd A bar. Right, suppose C divides BF in the ratio mu is to 1. Now the position vector of C, OC bar, that is equal to mu times 2 by 3 into A bar plus 1 into B bar divided by mu plus 1, that is equal to 2 mu divided by 3 times mu plus 1 into A bar plus 1 by mu plus 1 into B bar. Right, here this is OC bar, this is also OC bar. Now equating the corresponding coefficients, equating coefficient of A bar, equating coefficient of A bar. Here coefficient of A bar is lambda divided by 2 times lambda plus 1 is equal to coefficient of A bar in this is equal to 2 mu divided by 3 times mu plus 1. Right, here the coefficient of B bar is also same, that is lambda by 2 times lambda plus 1. This is equal to coefficient of B bar 1 by mu plus 1, 1 by mu plus 1. Right, now equating these two, mu plus 1 gets cancelled. That implies 2 mu divided by 3 is equal to 1. That implies mu is equal to 3 by 2. Right, mu is BC is to CF. Mu is BC is to CF, that is equal to 3 is to 2. Now we have to find the value of lambda. Lambda divided by 2 times lambda plus 1 is equal to 1 by mu plus 1. Mu is equal to 3 by 2. 3 by 2 plus 1, that is equal to 2 divided by 5, that is lambda by 2 times lambda plus 1. Now cross multiplying, 5 lambda is equal to 4 lambda plus 4, that implies lambda is equal to 4. Therefore OC is to CE is equal to OC is to CE is equal to lambda is to 1, that is 4 is to 1. Let us see next problem. The point E divides the segment PQ internally in the ratio 1 is to 2, and capital R is any point not on the line PQ if F is point on QR such that F divides QR in the ratio 2 is to 1, then show that EF is parallel to PR. EF is parallel to PR. Right? The point E divides the segment PQ internally in the ratio 1 is to 2. Right? Now this is a line segment PQ. This is a line segment PQ. E divides the line segment PQ in the ratio 1 is to 2. E divides PQ in the ratio 1 is to 2. And capital R is any point not on the line PQ. Capital R is any point not on the line PQ. Suppose this is capital R is a point not on the line PQ. F is a point on QR. F divides QR in the ratio 2 is to 1. Right? This is a point F divides QR in the ratio 2 is to 1. Then show that EF is parallel to PR. Then show that EF is parallel to PR. Right? This is EF bar. This is EF bar. And this is PR bar. This is PR bar. This is PR bar. Show that these two are parallel. Right? By using vectors, we have to show that the two vectors are parallel. Right? Let OP bar is equal to P bar. OP bar is equal to P bar. OQ bar is equal to Q bar. And OR bar is equal to small r bar. OR bar is equal to small r bar. Right? Now E divides PQ in the ratio 1 is to 2. Now the position vector of E, that implies OE bar. The position vector of E, OE bar is equal to 1 into OQ bar, 1 into OQ bar plus 2 into OP bar, 2 into OP bar divided by 1 plus 2, that is equal to Q bar plus 2P bar divided by 3, that is OE bar. Right? Now F divides QR in the ratio 2 is to 1. Now the position vector of F, that is denoted by OF bar. OF bar is equal to 2 times OR bar, 2 times OR bar plus 1 time OQ bar divided by 2 plus 1, that is equal to 2 times R bar plus Q bar divided by 3. That is OF bar. Right now our aim is to show that EF bar is parallel to PR bar. EF bar is parallel to PR bar. Right now consider EF bar. EF bar that is equal to OF bar minus OE bar, that is equal to, what is OF bar? OF bar is equal to 2R bar plus Q bar by 3 minus OE bar. OE bar is Q bar plus 2P bar, Q bar plus 2P bar divided by 3. By taking LCM, 2R bar plus Q bar minus Q bar minus 2P bar divided by 3. Q bar cancel, 2 times R bar minus P bar, R bar minus P bar by 3, that is equal to 2 by 3 into PR bar, R bar minus P bar, that is PR bar. EF bar is equal to, therefore EF bar is equal to 2 by 3 times PR bar, 2 by 3 times PR bar. Right, one vector is a scalar multiple of another vector. One vector is a scalar multiple of another vector. That implies EF bar is parallel to PR bar. Let us see next problem. Let OABC be a parallelogram and D the midpoint of OA. Prove that the segment CD trisects the diagonal OB and is trisected by the diagonal OB. Right? Let OABC be a parallelogram. Let OABC be a parallelogram. Let OABC be a parallelogram. Right? This is OABC be a parallelogram and D the midpoint of OA. Right? OABC be a parallelogram. Let OA bar is equal to A bar. Let OA bar is equal to A bar and OC bar is equal to B bar. Right? OA bar is equal to A bar, OC bar is equal to B bar. That implies by the parallelogram law of addition of vectors, OB bar is equal to A bar plus B bar. Right? Now D is midpoint of OA. D is midpoint of OA. That implies the position vector of, since D is midpoint of OA, since D is midpoint of OA, D is midpoint of OA, that implies OD bar is equal to OA bar by 2. OD bar is equal to OA bar by 2, that is equal to A bar by 2. Right? That is the position vector of D. Prove that the segment CD trisects the diagonal OB. Right? This is CD. CD trisects the diagonal OB. CD trisects the diagonal OB. Suppose let it be M. Let it be M. Right? Here we want to prove that the segment CD trisects the diagonal OB and OB trisect the line segment CD, right? For proving that suppose M divides OB in the ratio, suppose M divides OB, this is OB, this is the position vector of O bar, the position vector of B is A bar plus B bar. M divides OB in the ratio lambda is to 1. Suppose M divides OB in the ratio lambda is to 1. That implies OM bar is equal to, that implies OM bar is equal to, by using section formula, lambda times OB bar, lambda times OB bar plus 1 into O bar, 1 into O bar by lambda plus 1, right? That is equal to lambda by lambda plus 1 into A bar, lambda by lambda plus 1 into A bar plus B bar. That is OM bar. M also lies on CD. M also lies on CD, right? The position vector of C, that is B bar, the position vector of D, that is A bar by 2. M divides CD in the ratio mu is to 1. M divides CD in the ratio mu is to 1. Then OM bar, the position vector of M, that is equal to mu times OD bar, mu times OD bar. OD bar means A bar by 2 plus 1 into B bar divided by mu plus 1 divided by mu plus 1. That is OM bar, right? Now that is equal to mu by, that is equal to mu divided by 2 times of mu plus 1 into A bar plus 1 by mu plus 1, 1 by mu plus 1 into B bar, right? Now this is OM bar, this is also OM bar, equating the corresponding coefficients. This is OM bar, this is also OM bar, equating the corresponding coefficients. That implies coefficient of A bar, coefficient of A bar, that is lambda by lambda plus 1, that is equal to coefficient of A bar mu by 2 times mu plus 1, mu by 2 times mu plus 1. Now equating coefficient of B bar, here the coefficient of A bar and coefficient of B bar are same, so that this is also equal to, this is also equal to coefficient of B bar 1 by mu plus 1, 1 by mu plus 1. Now equating these two, equating mu by 2 times mu plus 1 is equal to 1 by mu plus 1, right? That implies mu plus 1 gets cancelled. That implies mu is equal to 2. That implies mu is equal to 2. It means that M divides CD in the ratio 2:1, right? Now substitute the value of mu in this. That implies lambda by lambda plus 1, that implies lambda by lambda plus 1, also lambda by lambda plus 1 is equal to 1 by mu plus 1, 1 by mu plus 1. That implies lambda by lambda plus 1 is equal to 1 by 3. 3 lambda is equal to lambda plus 1. That implies 2 lambda is equal to 1. that implies lambda is equal to 1 by 2. Right, the values of lambda and mu indicates that the values of lambda and mu indicates that the diagonal OB and the line segment CD trisected by each other. Right, let us see next problem. Let A bar comma B bar be non-collinear vectors if alpha bar is equal to, right, given alpha bar that is equal to x plus 4y into A bar, x plus 4y into A bar plus 2x plus y plus 1 into B bar, 2x plus y plus 1 into B bar, that is alpha bar is equal to x plus 4y into A bar plus 2x plus y plus 1 into B bar, and the second vector beta bar is equal to beta bar that is equal to y minus 2x plus 2 into A bar plus 2x minus 3y plus 2x minus 3y minus 1 into B bar, that is beta bar, right, given alpha bar is equal to x plus 4y into A bar plus 2x plus y plus 1 into B bar, and beta bar is equal to y minus 2x plus 2 into A bar plus 2x minus 3y minus 1 into B bar, right. There is a relation between the two vectors given that alpha bar and beta bar are collinear. The relation is 3 times alpha bar is equal to 2 times beta bar. 3 times alpha bar is equal to 2 times beta bar. By using this relation, we have to find the values of x and y. By using this relation, we have to find the values of x and y. Right? Substitute alpha bar and beta bar, that implies 3 times alpha bar, 3 into x plus 4y into A bar plus 3 into 2x plus y plus 1 into B bar, that is equal to 2 times beta bar. Beta bar is equal to y minus 2x plus 2 into A bar plus 2 times 2x minus 3y minus 1 into B bar, right. 3 times alpha bar is equal to 2 times beta bar. Substitute the vectors alpha bar and beta bar in this relation. Since A bar comma B bar are non-collinear vectors, by equating the corresponding coefficients, we get that implies 3 times x plus 4y, 3 times x plus 4y is equal to 2 times y minus 2x plus 2, and equating coefficient of B bar 3 times 2x plus y plus 1, 2x plus y plus 1 is equal to 2 times 2x minus 3y, 2x minus 3y minus 1. Now simplifying these two equations, these two equations, that implies 3x plus 12y, that implies 3x plus 12y is equal to 2y minus 4x, 2y minus 4x plus 4, that implies 3x plus 4x 7x, 12y minus 2y 10y minus 4 is equal to 0. Let it be equation 1. Now simplifying this equation, that implies 3 times 2x 6x plus 3y, 6x plus 3y plus 3 is equal to 4x minus 6y, 4x minus 6y minus 2. Right? 4x minus 6y minus 2. That implies 6x minus 4x, that is 2x, 3y plus 6y, that is 9y, 3 plus 2, 5 is equal to 0. This is equation 2. Right? Now solving equation 1 and equation 2, we get the values of x and y. Right? Now solving these two equations by using YC XY method, first write coefficient of y in equation 1. Now write constant term. Now coefficient of x. Again write coefficient of y. Now write coefficient of y in equation 2, that is 9. Constant term 5. Coefficient of x. Again coefficient of y. This is YC XY method. This is x, this is y, this is 1. That implies x divided by 10 into 5 50, 10 into 5 50 plus 9 into 4 36 is equal to y by minus 8 minus 35 is equal to 1 by 7 nines 63 minus 20. Right? X by 10 into 5 50 minus into minus plus 36 is equal to y by minus 8 minus 5 into 7 35 is equal to 1 by 63 minus 20. That implies x divided by 86, x divided by 86 is equal to y divided by minus 43 is equal to 1 by 43. That implies x is equal to 86 by 43, that is equal to 2. Y is equal to minus 43 divided by 43, that is equal to minus 1. Therefore x comma y is equal to 2 comma minus 1. Therefore the values of x comma y is equal to x comma y is equal to 2 comma minus 1. Right? ABCDEF be a regular hexagon with the center at O. Show that AB bar plus AC bar plus AD bar plus AE bar plus AF bar is equal to 3 times AD bar is equal to 6 times AO bar. Right? Let ABCDEF be a regular hexagon. ABCDEF EF be a regular hexagon. Right, this is A, this is B, this is C, this is D, this is E, this is F. These are the vertices of a regular hexagon with the center at O. Here this is a center. Here AD is a diagonal. AD is a diagonal. Center at O. This is the center at O. Right. Now here we want to show that AB bar plus AC bar plus AD bar plus AE bar plus AF bar is equal to 3 times AD bar. Right. LHS is equal to AB bar plus AC bar, AB bar plus AC bar plus AD bar plus AE bar plus AF bar. Right. AB bar plus AC bar, AD bar, AE bar plus AF bar. Right. In a regular hexagon, AB bar in a regular hexagon, AB bar is equal to ED bar and BD bar is equal to AE bar. Right. Now this is equal to AB bar plus AC bar, AB bar plus AC bar plus AD bar. Now AE bar. AE bar is equal to, here this is AE bar is equal to BD bar. This is AE bar is equal to BD bar. AE bar is equal to BD bar. This is a regular hexagon. AE bar is equal to BD bar. Now AF bar is equal to CD bar. This is a regular hexagon. AF bar is equal to CD bar. AF bar is equal to CD bar. Right. That is equal to AB bar plus BD bar, AB bar plus BD bar plus AC bar plus CD bar, AC bar plus CD bar plus AD bar, because the terminal point of this vector is equal to initial point of this vector. Now adding these two vectors, similarly C is terminal point of one vector and initial point of another vector. These two vectors also be added, that is equal to AB bar plus BD bar, that is equal to AD bar plus AC bar plus CD bar, that is equal to AD bar plus AD bar. Right, that is equal to AD bar plus AD bar plus AD bar, that is equal to 3 times AD bar, 3 times AD bar. Right, 3 times AD bar. Right, since O is the midpoint of AD, AD bar can be written as AO bar plus OD bar. AD bar can be written as AO bar plus OD bar, that is equal to 3 times AO bar, since O is center of AD, O is midpoint of AD, OD bar is the same as AO bar. AO bar is same as OD bar. Direction is same and magnitude also same. So OD bar is the same as AO bar. That is equal to 3 times 2 into AO bar. That is equal to 6 times AO bar. Right? Now I explain. This is a regular hexagon ABCDEF. We want to find AB bar plus AC bar plus AD bar plus AE bar plus AF bar. Right? Here AE bar is equal to BD bar and AF bar is equal to CD bar. Now adding the corresponding vectors, we get 3 times AD bar. Since O is midpoint of AD, so this can be written as AO bar plus OD bar. Since O is midpoint of AD, OD bar is same as AO bar, that is equal to 6 into AO bar. Let us see next problem. In a triangle ABC, if O is the circumcenter and H is the orthocenter, then show that first one OA bar plus OB bar plus OC bar is equal to OH bar. Second bit HA bar plus HB bar plus HC bar is equal to 2 times HO bar. This is very important problem. This result also be used in objective point of view. Right? This is a triangle ABC. This is a triangle ABC. This is a triangle ABC. In a triangle ABC, right, O is the circumcenter and H is the orthocenter. Right? Suppose O is the circumcenter. O is this. This is the perpendicular bisector of side BC. Suppose this is D. Now H is the orthocenter. Suppose H is this is the orthocenter AH. Right? H is the orthocenter. In any triangle, orthocenter, centroid and circumcenter are collinear. In any triangle, orthocenter, centroid and circumcenter are collinear. Right? This is orthocenter, this is circumcenter. Now join these 2 points. Suppose this is a centroid of a triangle G. Right? Now draw a median. Right? This is a median. This is a G. This is a G. Right? This is a triangle ABC. O is circumcenter. H is orthocenter. In any triangle, orthocenter, centroid and circumcenter are collinear. OD is perpendicular bisector. AD is the median of triangle ABC. AH is the altitude of triangle ABC. Right? This is the given data. Then show that OA bar plus OB bar plus OC bar is equal to OH bar. Right? See the figure. From the figure, triangle AHG, triangle GOD. Observe these 2 triangles. This angle is same. These 2 angles are same. This angle is same as this. These two angles are equal, and also these two are parallel. AH is parallel to OD, so this angle is same as this angle, and this angle in a triangle, two corresponding angles are equal. Automatically, third angle is also equal. These two angles are also equal, right? So the corresponding angles are equal in these two triangles from the figure. Triangle AHG, from the figure triangle AHG, from the above figure triangle AHG, triangle AHG, triangle GOD are similar triangles. These two triangles are similar. If the two triangles are similar, then the corresponding sides are in proportion. Then the sides are in proportion. It means that implies AH, the corresponding side is OD, AH by OD, AH divided by OD is equal to AG divided by GD, AG divided by GD, that is equal to HG divided by GO, right? These two triangles are similar, then the sides are in proportion. That implies AH by OD is equal to AG by GD is equal to HG by GO, right? In any triangle, centroid divides the median in the ratio 2:1. Centroid divides the median in the ratio 2:1. Also, centroid divides orthocenter and circumcenter in the ratio 2:1. That implies AH by OD is equal to, that implies AH by OD is equal to, AH by OD is equal to G divides AD in the ratio 2:1. G divides orthocenter and circumcenter in the ratio 2:1, so that AH by OD is equal to 2/1. That implies AH is equal to 2 times OD. AH is equal to 2 times OD. Here AH and OD are in the same direction, so that AH bar is equal to 2 times OD bar. AH bar is equal to 2 times OD bar, right? This is very important relation for proving the two results, right? AH bar is equal to 2 times OD bar. That implies HA bar is equal to, that implies HA bar is equal to, HA bar is equal to 2 times DO bar, 2 times DO bar, right? Now, since D is a midpoint of BC, since D is a midpoint of BC, since D is a midpoint of BC, D is midpoint of BC, then the position vector of D is, that implies OD bar is equal to OB bar plus OC bar. OD bar is equal to OB bar plus OC bar by 2, right? that is the position vector of midpoint of BC. Right, now the first bit OA bar plus OB bar plus OC bar is equal to OA bar plus OB bar plus OC bar is equal to, right, that is equal to OA bar plus OB bar plus OC bar. OB bar plus OC bar is equal to 2 times OD bar. OB bar plus OC bar is equal to 2 times OD bar, 2 times OD bar, right, that is equal to OA bar plus 2 times OD bar. 2 times OD bar, that is equal to AH bar. 2 times OD bar, that is equal to AH bar. Now here the terminal point of this vector is equal to initial point of second vector. Now adding these two vectors, we get OH bar, we get OH bar. Therefore, OA bar plus OB bar plus OC bar is equal to OH bar. Right, now second one, HA bar plus HB bar plus HC bar is equal to HA bar plus HB bar plus HC bar is equal to, right. So HA bar can be written as OA bar minus OH bar, OA bar minus OH bar. Similarly, HB bar is equal to OB bar minus OH bar, OB bar minus OH bar. HC bar is equal to OC bar minus OH bar, OC bar minus OH bar, that is equal to OA bar plus OB bar, OA bar plus OB bar plus OC bar minus 3 times OH bar, right. From first bit OA bar plus OB bar plus OC bar is equal to OH bar. From first bit, that is equal to OH bar minus 3 times OH bar, that is equal to minus 2 times OH bar, that is equal to, right, by eliminating minus, that is equal to 2 times HO bar, 2 times HO bar, we get the required result. Therefore, HA bar plus HB bar plus HC bar is equal to 2 times HO bar. Now, I would summarize this problem. Right, this is a triangle ABC. O is the circumcenter, H is the orthocenter, G is the centroid. Right, OD is the perpendicular bisector, AH is the altitude, AD is the median. Right, by using similar triangles property, there is a relation. AH bar is equal to 2 times OD bar. Also, D is a midpoint of BC. The position vector of D is equal to this. Now, first one and second one, we get the required results.